This is simple harmonic motion or wave motion examples, part B number 1 and part B number 2. For example, part B number 1, we have radio station WCRB in Boston broadcast at a frequency of 99.5, and then it gives us megahertz. So we have a frequency equal to 99.5 megahertz. If you look at your equation sheet, you'll notice that mega means times 10 to the 6th, though all we're going to do here is put 99.5 times 10 to the 6th hertz, because we need everything in hertz, not in megahertz. The speed of a radio wave, this is not what you hear, this is the signal that's transmitted, is the speed of light. So it's 3 times 10 to the 8th meters per second. That's the speed with which an electromagnetic wave will travel. We said in our lecture that we had that the speed of any wave is equal to the wavelength times the frequency. We know that the speed of this wave is 3 times 10 to the 8th meters per second. We're looking for the wavelength itself, and the frequency is 99.5 times 10 to the 6th hertz. If we divide both sides by 99.5 times 10 to the 6th, we end up with a wavelength equal to 3.02 meters. So radio waves are quite lengthy. 3 meters would be probably somewhere close to 3 yards or so. The very next problem talks about Clay. Clay is surfing, and he's surfing on a wave that propels him toward the beach with a speed, so we know that his wave speed is equal to 5 meters per second. We then read on to find out that the crests of each wave are 20 meters apart, so all they're telling us here is that the wavelength is equal to 20 meters. The first part of this, they would like to have us figure out what is the frequency of the wave. So we know that the speed is equal to the wavelength times the frequency. The speed is 5 meters per second. We want to know what is the frequency if the wavelength is 20 meters. So we divide both sides by 20, and we end up with a frequency equal to 0.25 hertz. So that is for part A. For part B, this is really simple. They just want to know what is the period for each wave. How long does each wave last? That's equal to 1 over frequency. That would be 1 over 0.25, and we ended up getting that here. And if you divide the two, you end up with a period of 4.0 seconds. And that is the end of wave motion examples B1 and B2.